Welcome to Ask and Learn.
So we take a parallel plate capacitor and then insert a dielectric that fills the entire space between the capacitor. And it stays connected to the battery the whole time. So U0, the energy stored before we put the dielectric in, is 1/2 CV squared, and V is delta V0. And then once we put the dielectric in, now we have 1/2, well, we have the same voltage because we're still connected to the battery, but the new capacitance is increased by kappa for the dielectric constant of the material. And like I said, we still have the same potential. So that means if we take the ratio of the two stored energies, that's going to be 1/2 kappa C delta V0 squared over this. And then you can see that the only thing that's changed is the kappa there, and everything else cancels. So we get a ratio of kappa. Now, in order for this increase in energy to happen, well, it has to be connected to the battery. Otherwise, there's nowhere for the energy to come from, and the field is going to do work to increase the energy. And like I said, we need the battery there, or else this wouldn't be possible, and we'd keep the same charge. So the next question is, what happens to the charge? So we can take the ratio of the charges as well as the energies. So the initial charge is going to be the capacitance times the voltage, which is delta V0. And then after we put the dielectric in, it's going to be kappa times C times delta V0. Now normally the voltage would change, so we get the same charge on each, but since the voltage is consistent, we're increasing in energy. So if we take the ratio of these, we get kappa times C times delta V0 over C delta V0, so we also get kappa. So everything is increasing by the same ratio of kappa due to the dielectric material.